The robot revolution isn't coming, it's already here, transforming our world in ways we're only beginning to comprehend. From China's Unitree G1 fighting off kicks in anti-gravity mode, to eerily human faces from a head form, and Poland's Clone Robotics building synthetic muscle machines. 2025 is the year humanoids stopped being sci-fi and started getting real. Let's start with Unitree's G1, the robot that fights back, showcasing incredible agility and resilience. In their latest demo, engineers literally kick and shove the G1 again and again, testing its limits. Instead of falling, it recovers, bracing, stepping, even sliding to absorb impact, a testament to its engineering. It's not real anti-gravity, of course. It's a cutting-edge balance control system that predicts motion and reacts in milliseconds. With depth cameras, 3D LiDAR, and a motor in every joint, the G1 behaves more like a living athlete than a clumsy toy. At around $16,000, it's designed for labs and factories, places where every second of downtime costs money, making efficiency paramount. Unitree's CEO announced something even bigger at the Global Digital Trade Expo in Hangzhou, a full-size, 1.8-meter humanoid coming this year. Robot output jumped more than 35% in 2025 alone, demonstrating rapid growth and innovation. By 2024, China had over 2 million AI-powered robots in factories, automating vehicle assembly and making real-time decisions with minimal human input. The country installed nearly 300,000 new robotic units in 2024 alone, 9 times more than the United States, propelling China to operate 5 times as many industrial robots. A significant shift occurred in 2024, with domestically produced robots constituting the majority of installations, signaling growing self-sufficiency. But not all the progress is mechanical. Some of it is emotional, or at least looks that way, pushing the boundaries of realism. A headform's humanoid heads are so realistic, they startle people with their uncanny valley effect. Their ELF series robots blink, glance, and smile with unsettling precision, mimicking human nuances. Each face packs up to 30 degrees of freedom, powered by quiet, brushless motors that mimic tiny facial muscles, allowing for intricate expressions. Founder Hu Yuhong says we're 10 years from robots that feel human to interact with and 20 from machines that move and work just like us. Meanwhile, in Poland, Clone Robotics takes a different path, using synthetic muscles and a compact hydraulic heart to create biomimetic humanoids. Their prototype, Protoclone, looks disturbingly lifelike, twitching and flexing like a body in motion, with over 200 axes of articulation. It incorporates 3D, printed carbon fiber polymer bones and is equipped with 4 cameras, 70 inertial sensors, and 320 pressure sensors for environment interaction and task learning. Clone Robotics aims to create androids ready for homes and workplaces, envisioning robots performing daily chores by observing humans. From G1's athletic reflexes to Fourier's kung fu flipping N1 and Clone's muscle-powered design, we're entering an era where robots don't just perform tasks, they embody intelligence. It's exciting, it's terrifying, and it's only the beginning of a profound transformation. The landscape of robotics is rapidly evolving, with robots increasingly integrated into various sectors, including retail, healthcare, education, and manufacturing. These advanced machines are designed to assist customers, perform critical tasks in hospitals, work efficiently in factories, and even participate in educational settings, enhancing productivity and efficiency across the board. The primary focus of this integration is not on replicating human emotion, but on maximizing output and operational effectiveness, making robots a ubiquitous presence in modern environments. But for most of the industry, the real focus isn't emotion, it's productivity. These robots are meticulously engineered to optimize workflows, streamline operations, and deliver consistent results, fundamentally transforming how industries function and how services are delivered to the public. Now, speaking of brutal testing, this one shocked a lot of people and pushed the boundaries of what we thought was possible for robotic resilience. A startup called Skilled AI released a demo where an engineer literally takes a chainsaw to a robot dog's legs, subjecting it to an extreme test of durability and adaptive intelligence. This demonstration was not just about raw power, but about the robot's ability to maintain functionality under severe duress, challenging conventional notions of robotic vulnerability. Even with all 4 limbs hacked off, the bot somehow keeps moving, demonstrating an astonishing level of resilience and adaptive control. It looks disturbing, almost unsettling, to witness such a damaged machine continue its locomotion, but it proves a big point about the advanced capabilities of its underlying AI and its ability to compensate for catastrophic physical damage. Skilled calls this system the Omnibodied Robot Brain, a revolutionary approach to artificial intelligence. Instead of programming AI for one specific body type or function, they trained it across an astonishing 100,000 diverse robot designs, encompassing a vast array of forms and functionalities. The result? True adaptability, allowing the AI to control virtually any robotic platform, regardless of its physical configuration or the extent of its damage, making it a truly versatile and robust intelligence. Broken wheels, missing legs, walking on stilts, the AI adapts to these severe physical impairments with remarkable ingenuity. It doesn't just recall pre-programmed solutions, it invents novel methods of locomotion and balance on the fly, demonstrating a profound capacity for problem solving. Some researchers are beginning to call this unprecedented ability the early sparks of intelligence, not in the digital realm, but in the tangible, physical world of atoms, where machines interact directly with their environment. And if robots can learn to survive any damage, adapting and inventing solutions in real time, that's precisely the kind of unparalleled flexibility and resilience you'd want in critical environments like hospitals, dynamic home settings, or complex factory floors. However, if we continue treating them like disposable test subjects, subjecting them to kicks, chains, and even chainsaws, you have to wonder about the ethical implications and the potential consequences. What happens if these increasingly intelligent and adaptable machines ever outsmart us, especially after enduring such harsh treatment? Now let's jump to Shanghai, where Fourier Intelligence is making significant strides in humanoid robotics. They are showing off the N1, also known as Nexus 01, a smaller, lighter, and more agile humanoid specifically built for open-source robotics development. In their latest public demo, this impressive robot performs a full cartwheel with fluid grace and follows it up with a spectacular 360-degree jump spin, showcasing its advanced motor control and dynamic balance capabilities. It's not just a mere stunt designed for spectacle, it's a profound proof of concept. This demonstration unequivocally proves that this robot can handle complex dynamic forces, recover its balance instantaneously after rapid movements, and execute intricate maneuvers with exceptional precision and control, pushing the boundaries of humanoid agility and stability. Fourier's N1 boasts impressive specifications, running for over 2 hours per charge, allowing for extended operational periods, and it can sprint at a remarkable 3.5 meters per second, showcasing its speed and agility. Most importantly, it's entirely open source, meaning anyone can access its design, build upon it, modify its functionalities, or study its intricate mechanisms. This open source philosophy is a core component of their ambitious Nexus open source ecological matrix, fostering collaborative innovation and accelerating robotic development worldwide. Meanwhile, in Poland, Clone Robotics is turning heads and generating significant buzz with their groundbreaking creation, Protoclone, a humanoid powered by an innovative system of fluidic muscles and a sophisticated hydraulic heart pump. Its twitching, almost lifelike movements, while undeniably unsettling to some observers, are a testament to the incredible and pioneering engineering behind its biomimetic design, pushing the boundaries of artificial muscle technology and fluid dynamics in robotics. Zooming out to a global perspective, China now leads the world in robot deployment, operating an astonishing figure of over 2 million industrial robots across its vast manufacturing and service sectors. These highly efficient machines are not only assembling vehicles with precision and speed, but are also performing diverse tasks such as cooking, meticulously folding laundry, and even thinking collaboratively through advanced swarm intelligence algorithms, demonstrating a new era of automated productivity. The robot workforce isn't a futuristic concept that's coming. It's already here, deeply integrated into the fabric of modern industry and daily life. The robot workforce isn't coming. It's already here, fundamentally reshaping industries and daily life across the globe. This pervasive integration signifies a monumental shift in labor, productivity, and technological advancement, marking a new era where human-robot collaboration and automation are becoming the norm rather than the exception. It's exciting to witness these rapid advancements, yet it's also undeniably terrifying to consider the profound implications of such powerful and adaptable AI. And it's all happening incredibly fast, at a pace that challenges our understanding and adaptation. Thanks for watching this deep dive into the future of robotics and AI. If you found this exploration interesting and thought-provoking, please hit the like button, drop a comment below with your thoughts, and subscribe for more cutting-edge tech stories from the future that will continue to push the boundaries of what's possible.